So today I will be demonstrating how to use SendMap to conduct like a network scan. SendMap is the official graphical user interface for Nmap. I will start with doing a ping scan. As you can see, it's important that I use the correct target. I tried a few different ones, as you can see. First of all, you see my own IP address, some different one, my school one, a different one from my school, a random IP address, and my own portfolio. I had some problems about it because everything got me a different result. So I will just do the official demo one, which is scanmedia.nmap.org. So starting with the ping scan, I will do the scan. As you can see, the ping scan are pretty fast because they simply check if the target is reachable over the network without actually scanning any ports. Looking at the results, you see the host is up, and it took like only 0.28 seconds to do this scan. I will do a regular scan next up. So let me see, yeah, then we just select a different regular scan over here. With the regular scan, it's a little bit different. As you can see, the command line is now also different. With the regular scan, we will also scan the ports being used. So it quickly identify open surfaces and potential vulnerabilities using like a regular scan. As you can see, we see several open ports like HTTP, yeah, right here, and SSH, which are open. Basically, in this step, it gives us information to like about which services are running on the host and could potentially be accesses or like exploited. So next up, we will do an intent scan, which is a little bit different because like a part of the scan is like crucial because we will dive deeper into the network and identify all available ports and services, providing like a big and complete overview. An intent scan is like not only just about the speed, it's also about precision. It will, like I said earlier, check every port. Ports like 22 for SSH or like 80 for HTTP are like standard, expected to always be open because it's like necessarily for services. However, there's like other ports like 31,337 known for like backdoor exploits. So if there's something up, it raises like a red flag demanding for like further investigation. It always takes a little bit time. As you can see the results, we noticed like several surfaces identified, including like the SSH and the HTTP, which are like essential for like the daily operations, but need to be secured and properly. The detection of the surfaces are like NetBIOS and Microsoft DS indicates like potential areas where security could be tightened. So in conclusion, this intent scan has provided us with some valuable insights into the security posture of our network. It highlights the need for regular updates, patch management, or like possibly reconfigurations or disabling unnecessarily services. It gives us like a big head up. So thank you for watching this presentation, and that's it. Welcome to my demo for OSZAP. Today I will be showing you how to use it. ZAP stands for like Set Attack Proxy. It's basically a powerful tool for finding vulnerabilities in web applications. It's crucial to note that when we use ZAP, we should only use sites where we have permission for that. That's also why today I will be using a demo website, which is specially designed for safe and legal testing purposes. As you can see, that is the URL, safe URL we're using. So what we're looking at is the automatic scan page. Here we put in the URL which we want to test. This site is set up to allow for penetration testing, which helps us to learn how to defend against real attacks without causing harm. Yeah, before I hit the attack button, let's talk a little bit about what happens during an automatic scan. With OSZAP can basically simulate real cyber attacks on web applications to identify vulnerabilities. It acts like cyber attackers. It acts like a cyber attacker, but in a controlled manner to help us strengthen the security of the application. Remember, launching an attack like this without permission can even be illegal or harmful. So I already started the scan, which is I did that because like it takes a while to gather some data. Because we're basically going to, as you can see, there's a few options like the IX spider, which basically means for some advanced JavaScript that we see on websites, and it will scan that. I'm also using the traditional spider, which fixes us to go through the URL and all the other sites and pages on the thing. So I'm already starting the scan, as you can see. While the scan runs, it's important to understand that websites for common security issues like we're checking the website for common security issues like cross-site scripting, SQL. As you can see, all the green dots are like the sites and things that we are looking at. If it's not, it will be at the flags. We can also look at the history button, the search. Here you have some information search. We can go to alerts. We can go to outputs. As you can see, like the data from alerts is also going up, spider, and so we will wait a little bit before we stop the test. We manually have to do this because it will not stop. It takes it will stop, but we have to get our data. So I will stop it now. After the scan, like right now, I will go to the report tab and I will have to generate a full report, which will detail all the vulnerabilities discovered during the scan, and those are categorized by their risk level from informational to high. There's a few things that we can change as well, like you see things like the name, the title, directory, the place where we can put the lab report. I put it at my desktop, which is a place where I like to have my documents. So going further, let's create it. As you can see, a new tab opens where we will see all the data, the report from the website that we just scanned from the demo. As we look at the report, each entry provides specific details about vulnerability, including its type, risk it poses, and the recommendation for mitigation. This detailed breakdown is like crucial, as it allows developers or security professionals to pinpoint the exact areas where security enhancements are needed. For instance, if we discover SQL injections, vulnerabilities, it highlights the need for stronger input validation and parameterized queries. As you can see, there's like a lot of things going on that we see. It's very detailed about everything that we find. You see a lot of things, alert types. There's some medium, low ranks, informational ranks, which are all things that we can look out and go further. For now, we will check out an XSS, which basically stands for cross-site scripting. Cross-site scripting allows attackers to inject like malicious scripts into content that other users will view. This can lead like to unauthorized access to user data, session hackings, hijackings, and other things that are just not good. So based on this report, we can mitigate this vulnerability. We need to ensure that user inputs are properly sanitized and validated. That means implementing encoding techniques and using frameworks and automatically handling these concerns where possible. Additionally, setting up content security policy. Headers can help mitigate the impact of any successful attacks by restricting the sources from scripts. When you think about it, addressing this vulnerability involves reviewing and updating code where user inputs are handled. It requires thorough testing to ensure that the fixes don't introduce new issues. Estimate the cost. Let's consider it would require about 15 hours for the developer to address, which could cost around $1,500. Depending on the developer's rate, this is a worldwide a good investment, as securing against XXS protects both the user data and the trust in the application. So that concludes my demonstration of OSAP. Using this tool allows us to take a proactive approach in identifying potentially vulnerabilities within our web applications. Regardless, deploying SAP scans in development and testing phases can help maintaining robust security standards and protect against evolving cyber threats. Thank you again. That is my demo.